Hi everyone, my name is Hakan and today we're building a .NET Web API using minimal APIs and Entity Framework Core. So if you want to follow along, there are a couple of things you need. First, which is the new .NET 9 SDK. So if you don't have it already, just go ahead and search for download.net and click on the first link. And right here, it should already auto-suggest the correct download for your platform. If you don't see your platform on here, just go ahead and click on all .NET 9 downloads. And right here, you can find all available downloads. Next is our IDE. I'll be using Rider because Rider right now is free for non-commercial use and it is cross-platform. So anyone on our Windows, Mac or Linux can follow along. And last but not least is Docker Desktop. In the first part of this video, I'll be using a in-memory database. So for that, I won't be using Docker, but later on, I'll be implementing a real Postgres database. And for that, I'll be using Docker to spin up a Postgres database inside of a Docker container. So if you want to follow along with that, just go ahead and make sure you have Docker installed. So if you don't have these things already, go ahead and pause the video and make sure to download and install these tools, and then I'll see you right back. So let's dive right into it. If you have downloaded and installed all the necessary tools, just go ahead and start up Rider, and this is the welcome screen. Here we'll be clicking New Solution. Then on the project type, we'll be picking Web, and we'll give us our solution a name called Books, and our project will be called API. These we can leave unchecked, and for the target framework, make sure you have .NET 9, and for the template, pick the Web API, and the rest can stay default. Then go ahead and click on Create. So our project has been created. Inside of the API project, we can see that there isn't much going on really. We have one file, the Program.cs, which contains the Open API registration, which is the new API documentation replaced for Swagger. In .NET 8 with Swagger, but because that isn't maintained really anymore by its owner, Microsoft replaced it with the Open API. And we can see a template for a minimal API for getting random weather forecasts on this endpoint. And we can see a record that's being used as a DTO inside of this endpoint for the response body. We have our app settings files, which contain our configuration files, which then again can be used inside of the program.cs or anywhere in your code really. And we have a HTTP file, which can be used to test your API endpoints by sending a request through this file when your API is running, and then you can see the response right here inside of the IDE. So to show you how it works, I'll just run the API. So the API is running, and then when I click on this run button, it sends a request to this URL. And now we can see that we get a 200 OK response with the appropriate response body. So it works pretty okay. It's nice. It does the job, but I'm not a huge fan of these HTTP files. I much rather have some sort of UI for testing my API endpoints. With .NET 8, I used to do that with the Swagger UI, but because that's gone now, I'll be replacing it with the new package called Scalar, which is getting pretty popular already. So to install Scalar, all we'll do is go to the NuGet and say search for Scalar, and we have this scalar.AspNetCore package, and we'll just click on install. And to make this work, all we have to do is inside of this if bracket or if block, just say app.map scalar API reference, and that's really it. And one more change is inside of the launch settings, we'll say launch browser, set that to true. And then we'll say launch URL is equal to this URL, and then scalar v1. So what this will do is when we start our application, it will automatically launch at this URL, which is the new Scalar documentation. So when I run my API, I get this beautiful Scalar documentation, which looks pretty nice, pretty modern. That definitely looks better than the old Swagger documentation. And inside here, we can see our models, the weather forecast model. We can see our endpoints. And what we can do is send a test request by clicking on test request and then click on send. And then right here, we'll see our response body and the 200 OK status. So during this demo, I'll be using the Scalar documentation for testing my API endpoints. You can also use something like Postman or Insomnia, but this works pretty great, easy, looks great. I like it, so I'll be using this. So back to our IDE, and let's start implementing our own endpoints. So before starting, I'm gonna clean up this program.cs file by deleting this record, deleting this endpoint, and deleting all of this. Okay. Then I'll start by creating a model, or create a new folder called models, and inside of that we'll create a new class called book. And a book will contain three properties. The first, which is a GoId ID. Then we will contain a title of type string. And last but not least, a string ISBN. So I'll make all of these required. And I'll make this one init only and this one init only because I don't want these to change after creation. So before implementing our endpoints, first I'll be installing the Entity Framework Core package to set up our database. So we'll go to the NuGet manager and search for in-memory. And here we have the Microsoft.entity-framework-core.inmemory package. Go ahead and install this one. And then I'll create a new folder called data. And inside of here, I'll create the books context, which will represent our database. And this will inherit from the DB context and contain a property of DB set of type book. It will be called books. Then it will have a constructor which injects the DB context options, DB context options of type books context. And it's called options, and give it to the base class options. Okay, that's all we need to do for now. And we'll also need to add our DB context to our services. So we'll do is builder.services.add DB context of books context. And in here we'll define that we want to use the in-memory database. So we'll say options.use in-memory database. And we'll just give this a name of booksDB. So that's all we need to do for setting up the database, or the in-memory database in this case. So next we'll be adding our CRUD endpoints. So that means we'll be creating endpoints for creating books, getting books, updating and deleting books. We can define them right here inside the Program.cs because of the way how MinimoAPI works. We use extension methods on the iEndpoint route builder. And the app is a web application which inherits from the iEndpoint route builder. So we can call those extension methods on the app instance. So we can do things like app.mapGet, mapPost, or mapDelete. So all the HTTP verbs are available, mapPut. So we'll start by creating a book. So we'll say mapPost. And as a first argument, it takes the URL, so API/books. And as a second argument, it takes a request delegate. So here we'll say async, then we'll create a method. And we'll also give this a name right away. So we'll say with name create book. And inside of this delegate, we'll just, let's do it like this. This delegate will have an argument which will be the books context, and we'll have two arguments actually, which is the request object, so the body, and a books context, which is our database. First I'll be creating a request object, so there will be public record create book request, which will have a title and an ISBN. Okay. And this will take that as an argument, so create book request, and then we'll inject the books context, which we'll call context. And in here, to keep things simple, I won't be dealing with validation today. So I'll be creating a book right away by saying for book is new book. And we'll assign it an ID, which will be a GUID.create version 7, which is available since the release of .NET 9. And what makes these IDs special, these GUIDs, is they have a timestamp into them. So they are sortable, which is a nice feature. And then we have the title, which is the request.title. And we have an ISBN, which is the request.isbn. Okay. And to actually add these books to the database, all we do is say context.books.add_book. And to persist the changes, we have to call the saveChangesAsync method. So we'll say await context.saveChangesAsync. So if we don't call this, nothing will be persisted to the database and nothing will be actually saved. This just creates a context in memory, and if you don't call the saveChangesAsync, it won't do anything with it. So you really need to call the saveChangesAsync to actually persist changes to the database. And what's also nice is that the DB context, this DB set acts as a repository on the context, which also acts as a unit of work. And on these repositories or these DB sets, we can use link. So we can say anything like context.books. Say first or default async. We can filter with the where method. We can find entities by their primary keys with defined async. We can add, we can remove. So all the link methods are available because this also inherits from IEnumerable. So that's pretty nice. We don't, with anti-framework core, we don't have to write any SQL of our own. We just use link, which will be converted to SQL. Because we're using an in-memory database right now, there won't actually be any SQL generated because it will actually use some type of in-memory lists. But later on, when we will implement a real database, then we can see that those link methods are actually converted to SQL. So next is getting a book. Or first I'll need to return here a results.created add route. Let's say get book. Let's give it the ID as a parameter. Let's say book.id. And also give it the book. Okay. And next is our get method. So we'll just copy this for now and say map get API books /id coit. And this ID in the route will be injected in this methods. So we'll take that as an argument, say code ID. So this ID will map to this ID in the route. And what we'll do, we'll delete this for now. And say if our book is await context.books.findAsync. So we have multiple options here. We can say find async, we can say first or default async, and use a predicate to find the book by its ID. Or we can say something like single or default async to make sure that there's only one inside the database, but because it's a primary key, we're already pretty sure that's only one. And so the fastest method in this case is the find async, especially if you're not using any other link methods, because it won't work if you have something like where, let's say book.title is something, and then the find async won't work on this. So it really has to be right away on the DB set, so find async. So if you're doing anything with filtering or including, which means joining other tables, you can't use the find async, but in this case it's fine to use it. And if this can't find the book, it will just return null. So we'll have to check for that. So we'll say if book is null, return results.notfound. And if it's not null, then just say you can actually use a ternary operator right here by saying return book is not null. So results.okay book else results.notfound. Okay. And let's call this get book. And next, maybe we'll want to get a list of books. So what we'll do is just copy this one and remove this part of this URL and remove this argument. And then we'll say for books is await context.books.toList async. So if we don't use any like any where filter on here, what this will do is just get all the books out of the database, out of the books table. and then we can just return it right away. Say results.ok books, and let's call this get books. Okay, so this should be working. Let's start our application. So here's our Scalar API documentation, and right away here we can start with creating a book. So I'll just click on the endpoint and let's send a test request. And let's give the title of my book, and let's give the random ISBN, then send it, and then we get our created book. And the header, it should right away show the location of the resource, which is exactly the same as our get book endpoint. So the endpoint for getting a book by its ID. So if we use this, paste the ID, send it, and then we'll get our book. And also if we create another book, so let's, and where is our endpoint test? And then my book 2, give maybe another ID, send it, my book 2. And if we get the list of books, sent, we get a list of 2 books. So that seems to work fine. Let's go ahead and implement our other 2 endpoints, which we'll be updating and deleting. So back to Rider, let's implement our remaining 2 endpoints, which we'll be updating and deleting. So our update book endpoint will be pretty similar to this endpoint. So let's just copy this and let's say map put, which also takes an ID, but which also takes a update book request. So we'll just create a new DTO for that. Update book request, and we only want to allow title changes, title updates. So all we do is add another argument here saying update book request, update request, and let's call it request. This should be called update book request. Okay. And then all we have to do is find our book, and if it is null, then we won't update it because nothing has been found. So we'll see, we'll do something like if book is null, return results.notfound. And if it is not null, then we'll update the title. So we'll say book.title is the request.title. And then to persist that to the database, we'll call the save changes method again by saying await context.savechanges async. And then we'll just return the book by saying results.ok book. And we'll call this update book. So how this works is the anti-framework core has this thing called the change tracker. So once a entity is being received from the database, the change tracker observes the entity, and if there's been any operations on it, then the change tracker will register that. And when the save change async is called, all those updated or all those operations will be persisted to the database. So with anti-framework core, you have this option to not track the changes. So you can do something like as no tracking. If you use this, then this won't work. Then you really have to do it another way. But when the change tracker is active, then this will work fine. You can just update the book by setting the property to a new value, call the save changes, and the changes will be persisted to the database, which is a really nice feature. And then last but not least is the delete endpoint. So I'll just be copying this and say map delete, and then we'll get an ID again. We can remove this update request. And then again, we'll find the book, and if it is null, then return not found, and else we want to remove the book. So we'll do that by saying context.books.remove book. And then again, save the changes and persist the removal to the database. And instead of the book returning the book, we'll just say results.ok, or maybe better, no content. And let's call this delete book. Okay, so that should work. Let's test it out. So because we're using an in-memory database, it will be empty every time we start our application. So we'll start by creating a book. So let's give the title, my book. Let's give the random ISBN, send it. We get a created book. And right away we can update that book by using the update method. Test the request, give it the ID, and then give it a new name, say my book updated. Send the request, and then we get the book back with its new title. We can also check that by getting a list of books, and we'll see my book updated also with the getting a book by its ID. Insert the ID and my book updated. So that works. And also checking the delete endpoint. So let's try and delete the book. We'll insert the ID. Maybe we'll insert something else. Let's change one thing. Then we'll get a 404 not found. If we insert the right ID, we get a 204 no content, which means the book is deleted. So if I send this request again, I get 404 not found because the book doesn't exist anymore. So back to Rider. We got one problem right now because we've defined all the endpoints inside of the Program.cs. Once we keep adding endpoints to this file will get pretty huge and it won't really be maintainable, or it won't be nice to maintain it. So what we'll do is put all this code inside of a separate endpoint file. So what I'll do is create a new folder called endpoints, and then I'll add a class called book endpoints. And this will be a static class because we'll be creating a static method on that endpoint route builder, which is available on the web application. So we'll say public static void, or let's say endpoint route builder, and then say map book routes, and say this endpoint route builder, or let's call it app. And then we can say return app. And what we can do is copy all of this code and just go ahead and paste it inside of here. And that should work. So let's add the using directives. Next, what we'll have to do is on the app, we'll have to call this method, say app.map book routes, map book routes, and then everything should still work the same. So back to the Scalar API documentation, let's test if our API still works. So let's create a book by sending it a test, send to one created, okay. Let's use the ID to try and retrieve the book. So we'll say get the book ID, and we get the book. We can still make changes to the book. Let's say update, and up, and we get the updated book. And we can also delete the book by adding the ID and on delete 204 no content. Send it again, 404 not found. Okay, everything still works the same. Next, we can clean this file up a little bit by introducing a group route builder, or a route group builder it's called actually. So what we can say is for group is app.map group, and give the URL of API/books dot with tags books. So what this allows us to do is, instead of using these map post map gets on the app, we can use them on the group, which will all share the same URL. So what that will look like is I can say app group. Okay, and then what I can do is remove these URLs and just replace them with a slash. Remove this one, remove these, remove this, and remove this. So we have a little less duplication, and the rest stays the same. Once we start the application again, we can see that still all our endpoints are there, even though we changed the URLs inside of the map verb methods. But because we're using a group, they all share this API/books URL. And last but not least, let's move these DTOs inside of their own files to clean up the program.cs. So we'll just do that. And we'll move this to its own type. And then we'll create a new folder called contracts and move those files to that folder. And all we'll need to do is sync up the namespaces. So what we can do is right click on the API project, and then we can say refactor this, adjust namespaces, click next, and then they've got the respective namespaces. So now that we have refactored our code from moving all of our endpoints from the program.cs into the book endpoints.cs, one thing remains, and that is getting rid of this in-memory database and swapping it out with a actual Postgres database. So to do that, first we'll need to install a new package, and it's called the npg/sql.entity-framework-core.postgresql. So we'll start by installing this package. And then instead of options.use in-memory database, we'll use options.use npg-sql. And as an argument, this takes a connection string. So let's move this to the next line, and then we'll get that connection string from the configuration, so from the app settings file. And for that, we'll say builder.configuration.getConnectionString, and we'll say books.db. And then next is we need to add that connection string to our app settings file. So we'll open up the app settings file and then add a new section called connection strings. And here we'll add a new key called books.db, and then we'll add a connection string which will look like this. Server is localhost, port is 54302, which is the default port, and then we have the database name, which is books.db, and then we have the user ID, which will be Postgres, and then we have the password, which for now we'll also call Postgres. Okay, so that should be it. Next, we will install the .NET EF tool, which is used for creating migrations for your databases. So open up a command prompt or terminal, PowerShell, whatever you like, and use the following command, say .NET tool install, yeah, that's pretty much it. Install global .NET EF version 9. So go ahead and click enter. I've already got it installed. So after installing the .NET EF tool, just go ahead, go to your terminal and cd inside of the API project. So cd API, and then call the .NET EF migrations at initial create. And right now this won't work because we're still missing a package. So if I run this, it will start building and say it doesn't reference the Microsoft.entity-framework-core.design package, which is needed to create migrations. So let's go back to our NuGet manager and just let's search for design. And then we have the, let me see, or entity framework core.design. And it's right, this one, Microsoft.entity-framework-core.design. Go ahead and install this package. And after successful installation, just go ahead and run the command again. Build started, build succeeded, and we've got our migrations. So after successfully running the migrations command, we have a migrations folder now, which contains our migration file. So this migration file is nothing but a set of instructions for Entity-Framework Core to create an actual SQL migration. And what it does, it contains two methods, an up and a down method. And we can see that inside of the up method, a table will be created with the name books. And the name books comes from this books context of the DB set of type books, or which is named books. If I'd named this something else, then that name would be right here. And we can see that the book model is being used. So our properties that we set, the ID, the title, and the ISBN. And Entity-Framework Core also automatically detects that the ID will be used as a primary key, because Entity-Framework Core works by convention. So that means if you have the word ID in a property, it will automatically use that as a primary key. You can also explicitly explicitly configure that by going to your models and use these data annotations like this. You can say this is a key, so then Entity Core will know that this is a primary key. And for these other properties, you can do things like max length, let's say 100, and then ISBN should be max length, ISBN should be 13. So to see if that works right now, let's just go ahead and delete these migrations and then just run them again. .NET EF migration at initial create, build started, build succeeded, and we have our new migrations. And to see if that works, there it is. Inside here, we can see that the title should have a max length of 100 and the ISBN should have a max length of 13. So you can use these data annotations that I showed, or you can create entity configuration files, which looks like this. If I add a directory inside of the data called config, and I add a new class here called book configuration, and this will inherit from entity type configuration of type book, and this will implement this interface. And in here, the builder, that's pretty much what this model snapshot contains, this entity type builder. So it works pretty much the same as here. We call this the Fluent API for configuring our entities. So inside of this book configuration, we can say builder.toTable, and let's call it book instead of books. And we can say builder.asKey, which is entity.id. And we can configure all the properties like builder.property, .title, is required, so it should not be null, and has a maximum length of, let's say, 100. So we can do the same for the ISBN, where we just say ISBN is required, has a max length of 13, and is a fixed length actually, because an ISBN should be a length of 13. And I can also rename this to something else, but just show how it works. To make this work inside the books context, we have to add these configurations. So for that, we'll need to override the model on model creating. And then here we can do model builder dot apply configurations from assembly. And then we'll just say assembly dot get executing assembly. So what this will do is check the assembly and check for all the files that inherit from, or all the types that inherit from entity type configuration. And we'll use these configurations to create the migrations. So just to see that it worked, let's change this 100 from 100 to, let's say, 200 for now. And then we'll delete the migrations again. So let's go ahead and delete. And then we'll call the command. And we have our new migrations, and see if that worked. There it is. So now we have a max length of 200 and we have a character of 13. So that's another way to configure your entities, by using this Fluent API. And after the creation, just make sure that inside of the books context in the on model creating, you do the assembly get executing assembly, or what you can do is you can also do something like this. If you don't want to use this method, just say apply configuration, and then you can say new book configuration. This will do the same, but then you'd have to do this for every type of configuration, and just using the assembly marker just makes life a little bit easier. So next is spinning up the database and actually creating the database. So for that, I'll be starting up Docker. And right now I have no containers or images. So first I'll need a Postgres image. So in here on the search bar, I just search for Postgres, and then I'll start pulling it. So now that I have the Postgres image pulled, I can create a container out of this. So all I do is click on run. click on optional settings, then add the port and some environment variables by saying Postgres user is Postgres. Then I'll add the password. Should all be capital, so password is also Postgres. And just go ahead and click run. And then it will start creating the database inside of a Docker container. And now we should be able to connect to this database. So right now we can use the .NET EF tool to allow the migrations to be created and create the tables inside the database. So for that we'll do .NET EF database update. And just go ahead and click enter. Build started, and there it is. So now you see the SQL being outputted. It says create table, ID, title, ISBN, constraints, primary key. And yeah, so now we have a Postgres database. To check if it exists, we can go ahead and connect to it by going database. Let's see, connect to database. Use source manually. Next, I want a PostgreSQL localhost. User Postgres, and database should be booksdb. That's connection. This should be books, and that's connection succeeded. Connect to database. And there it is. We have our database with our books table and our 3 columns. So AntiFramework just created a database for us. We didn't have to write any SQL for that. AntiFramework just does everything for us. And the power of AntiFramework right now is that we don't have to change any of our implementation code, because all of that's being abstracted away by AntiFramework, all the SQL that's going to be written. So it doesn't matter whether you have a in-memory database or a SQL Server database, Postgres, SQLite, any type of database that AntiFramework supports, you can write one implementation and it should work for all of them. So let's test if our application still works by starting our app. Let's click run. And here we're back on the Scalar Open API documentation. And then let's go ahead and start creating books again. So we have our first book. Let's call it again my book. And then we need an ISBN. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4. Let's send it. So our book has been created and it should show up in our database. So if we go to Writer and check out our column and let's say edit data, and there it is, our book with our ISBN, our title. And let's go ahead and test our other endpoints. So getting a book by its ID. And what was the ID? I'm just gonna copy this. Then I'm gonna get a book by its ID, send it, and I've got my book. Also the books endpoint where I get a list of books. And let's try and update the book. So we want to change the book with this ID and call it updated book in database. Send it, the book is updated. Let's go ahead and check the database. Let's refresh this and we'll see updated book in database. So that works, and we can also see the SQL output right here in the terminal. So when fetching a book, it's doing some like selecting all the properties from the book table where ID is equal to, and it sets a limit of 1. So AntiFramework does all of this. It translates those link queries into actual SQL queries, and if it is a Postgres database, it uses queries. It uses query syntax for Postgres. If this will be a SQL Server database, it would look a bit different. You won't see these signs, but you would just see brackets. 1, 2, 3. So to test our last endpoint, our delete. So let's go ahead and take this ID again. Let's go to delete endpoint, test request, give it the ID, send 204, no content, so it means it has been deleted. If we send it again, 404 not found. So that means our book has been deleted. And if we refresh, we'll see that our book has been deleted from the database. So everything seems to work just fine. I haven't changed any bit of implementation. So that's really a big win from AspNetCore. So there you have it, folks. That's how to build a web API using minimal APIs and AspNetCore. As you can see, a minimal API can be built in pretty much minutes. Depends, of course, on how complex or simple you want to make. For this demo, of course, I didn't look at anything like security or validation. So for that, these APIs are built pretty much in no time. But of course, in a real production application, you wouldn't build it like this. But just now for doing a showcase, I think it's fine. So we've created some minimal API endpoints. We've used AspNetCore first with a in-memory database and swapped it with a actual Postgres database. And we've seen that none of the implementation has changed. I could change some implementation, but that's not really needed. It works just fine. So I'll just leave it like that. So yeah, that was how to build the API in ASP.NET Core. Thank you for watching, and I'll see you next time.